So good morning, folks. Thanks for joining us for the Database in Memory office hours for February 2021. Joining me today is Andy Rivnes, who is, of course, our Database in Memory expert. My name is Maria Colgan, and between the two of us, we're hoping to share all the information we've got on Database in Memory and today, blockchain. So Andy, over to you.
Thanks, Maria. Hello, everybody. Yeah, so today we're going to talk about blockchain tables and database in memory. So we get the pleasure of hearing a little bit about blockchain tables from Maria, and then I'll take over and kind of show you, we'll actually go through a demo and we'll build a blockchain table and play around with it a little bit and then try it with database in memory. As always, our landing page here, I have this up that you would have connected to initially, has below it, to remind everybody, try to do that each session, that we have both resources available and then our previous sessions as well. So if you want to go back and look at our previous sessions, last month, I guess, we did what the new 21C features for database in memory. So you could go back and look at that, or any of the other things we've talked about. So recognize that there's resources there. And with that, I guess we can get rid of this. And then I will just wanted to briefly make sure everybody understood or knew that my name's Andy Rivnes and my Twitter handle's there if you want to follow me. And my email address, if you have questions later, I'd be more than happy to answer any questions. And of course, Maria, you can follow her at SQL Maria. And she's been doing, what was the last one was a series on different table joins, I think, was what you were doing on SQL Maria. And then she's always speaking at different places. So definitely, if you see that she's available, you should hear what she has to say, because it's always interesting. And I think you want to launch into kind of describing blockchain tables initially.
That's right. I thought it would be great if we just give people some background, because blockchain tables are a new feature in 21C. I thought if we started there, then we can jump in and actually show them how blockchain works with database in memory. So I thought it'd be good for us to just have a quick intro into this blockchain technology. And when we think about database security, we think about all of the technologies we currently have that keep criminals out of our databases. So we, put passwords on them. There's roles and privileges for users to minimize what they can see inside the database. We encrypt the data at rest. So even if somebody steals the drive, they can't see that data, and so on. But there is still one layer that we're exposing our data to, and that is, of course, being vulnerable to illicit data changes. And these are changes that can be made by a corrupt insider. So somebody who has legitimate credentials to get on that system, but then has access to change or, worst case, delete the data inside in that database. The same is true for criminals who may use a phishing attack to get a legitimate set of credentials to get onto that system. And of course, there's always the threat of a hacker who will exploit a security vulnerability and gain access to our system. And so it's for this reason that Oracle is introducing these new blockchain tables, because we want to bring the key security benefits of blockchain technology to our enterprise applications. So we don't want to have to re-engineer everything. We want to make this super simple and transparent to the applications. And that's why Oracle is introducing these new blockchain tables, so that we can prevent these data changes. And it's incredibly easy to do. We're simply going to add the new keyword blockchain to our create table command. And Andy's going to show us some examples of this and how it works within memory in just a second. But what is a blockchain table? Well, it's an immutable table or an insert only table that is going to automatically chain the new data coming in to the existing data within that table. So how do we do that? Well, we create something called a cryptographic digest. And that cryptographic digest is basically a hash signature that is built using the information in the newly inserted row and the crypto digest from the previous row. Using those in combination, we create this new unique crypto digest, and that's added in the background or invisibly to each of the rows in the table. And because we have that chain, we can then verify that nobody has damaged or interrupted this table, because we can check or verify the chain is still there. Now, what's great about this is it's built into the Oracle database. So it's available in all of the versions of the database. So there's no special features or options required for it. It's not a blockchain only database. It's part of the core Oracle database. And of course, you can access it using standard SQL. So whether that's using it as part of transaction processing or for analytics, it's easy done. And the other great advantage is it's going to protect you from all of these multiple attacks. So for example, it's going to protect you from illicit changes by those insiders or criminals using stolen credentials. Because it doesn't allow any DML, so you can't, other than inserts, so there's no deletes or updates allowed. It also, of course, is going to protect you from anybody who's stolen legitimate credentials, because one of the things I didn't mention, but is possible, is that a user can sign their data as it's being inserted. And so they use their own private key to do that signing of the data. And by doing that, that way, if somebody steals their credentials, they will be missing the ability to sign it as that legitimate user. And so even though they may be entitled to insert into that table with the stolen credentials, the data will be flagged as not being signed by the correct user and therefore not valid. And of course, we want to make sure that we can protect against hackers as well. And so with the cryptographic chain data set, with the cryptographic chained data block, oh my goodness.
That is a mouthful, isn't it?
Yeah. With cryptographic chain of our blockchain data, we can protect against any changes that even those that people are trying to bypass SQL to change the data. So for example, if the hacker gets onto the operating system and is trying to change the data at rest, then they'll actually break that blockchain cryptographic digest, because when we go back and we verify, and Andy will probably show us do this in the demo, you can verify the blockchain and prove that the chain is intact and that no one has tried to change the data. If a hacker was to change the data out on disk, then that chain would be broken, because when we would reverse engineer the hashing functions that have been used to create those digests, they wouldn't be valid because the previous chain or entry in the table would have changed. And so that also allows us to independently validate if you want. So you have the ability to publish the blockchain without sharing the actual data in the table via REST or email, whatever you want to do, so that you could have it independently verified as well if you wished, so you don't have to do it yourself. Now, as I mentioned earlier, this is a completely free feature inside in the Oracle database. So Oracle database 21C and 19.10, I believe, and 19.11 will have immutable tables and blockchain table backported into them. So if you're moving to 19C, make sure you're on the latest RU, and you will also have access to blockchain tables and immutable tables going forward. And what's, as I said, is great is that it's pretty much transparent to the application. And you can get a ton more information on the blockchain blog itself. We also have hands-on labs to help kind of guide you through what to expect with blockchain tables and how to use them. And of course, there's plenty of documentation. But with that, I'm going to hand you over now to Andy, who's going to show us how all this works with database and memory.
Thank you, Maria. Yeah, so actually I asked me how I discovered this, but yeah, so actually it's 19.10 or higher, because I initially started my demo and realized I didn't have compatible parameters set high enough. And yeah, so I guess the 19.10 RU, so anything above that, you can use blockchain tables. So I figured I'd put that in there since the system I've got now is higher than that. So let's see if let's take a look at some of this. So let's see, I'm gonna stop the share for the screen and put it just for the VirtualBox. So hopefully that'll be big enough for everybody to see. So can you see that? Is that okay?
Yeah, that's great.
Yeah, okay.
Now it's much bigger.
All right, so what I've got is, actually I'm using 21C, but like I said, 19.10 or above. So what I thought would be fun to do is, I don't know, I didn't put one of the things in this that Maria mentioned, but what I did is I've connected to the database, and we're going to create, I don't have any tables created, nothing in the column store. So we're going to start on a fresh schema. I'll talk a little bit about why we're going to do that in a second. But initially, what we're going to do is create a blockchain table. We're going to call it trade ledger. So I'm going to use the same format that Maria had in her slides. So if you decide to go back and look at the recording, hopefully this will all flow. That was kind of the intent. Notice that I put in here, I discovered this yesterday because originally I had set up a test where I had something like 1 or 0 days. And I'll hopefully at the end, I'll show you an example of, because realistically, blockchain table, you're gonna want to make sure nobody can change it, drop it, and then recreate it, maybe sneak something in. So you wouldn't normally put 0 days, but Oracle is really serious about the fact that you can't muck with the table once it's created. That's kind of the whole point of the security end of it. So if you would normally probably put a much longer time period, and as I discovered, you can't drop it. You literally have to drop the schema apparently to clean it up if you want, and when you're doing like testing. So fair warning that I just set that there so to make it easy, my life easier, but normally, not only can you not, we'll kind of go through it, not stick or change data, you can't even drop the table, which kind of makes sense. It kind of flows, right? So anyways, we've created, now notice blockchain, we've told the database it's a blockchain table. We've added some other parameters that I'm not going to really go into, but suffice it to say that we're setting it up such that we can track these change and cryptographic. That's a mouthful. So crypto I like better because it's easier to say it. But and then again, you can go read about it. I didn't know there was a Live Labs already out there for it, so that's cool. And so you could play around with this. And let's add just some data in here. We're going to insert a couple of rows just so that we have something to work with. So I've basically just inserted we should commit that, a bunch of rows, well, actually 4 rows, same rows that Maria had again in her demo. And so if we then look at, I had to do a little, cutting and pasting is way better for me than you want watching me type. But basically, it's a pretty simple table: ID, user, value. That's all we've got in there, and I've added some pretty simplistic rows into it. But what's interesting, I thought, and I was trying to duplicate what Maria had done in her presentation. And so what I've got is under the covers, Oracle's actually created a whole bunch of additional columns and attributes to keep track of the data in the table, to make sure, as she said, the cryptographic sequences are all kept together. And so there's actually more that goes on underneath the covers. Notice that they are hidden, though. These columns are hidden. You don't normally ever need to know about them, but I just thought it was interesting as I was playing around with this a little bit to see that there is more to it perhaps than meets the eye, because Oracle is made quite a bit of effort to make sure that we meet the blockchain requirements. So what else? Oh, and then we can take a look at, this was my attempt at duplicating Maria's picture. Notice that what I've done is I've shown you the 3 normal values that you would see in the table, but also that there's a creation timestamp. So you could create your own, you could at the application level manage when rows were inserted, or Oracle's doing that for you. So you can display that as a timestamp or format that to something more friendly. And then you can get the hash as well. I don't know what you would do with that, the signature hash, but you read about it and decide whether any of that matters. I think the big thing that Maria mentioned was the fact that you can then go back and validate. There's quite a few procedures available with the blockchain, and you can do a verify rows to make sure that nobody's tampered with that data. And so there's all those details, which we're not going to really get into because we're database and memory guys. But I just kind of wanted to point out that there's quite a bit of stuff going on under the covers. And I found it actually quite interesting to take a look at. There's also a more simplistic view of this, which I thought for me works a little bit better. There's actually just a blockchain, user blockchain tables that you can then show kind of an overview of the blockchain table, or if you had multiple blockchain tables. And notice our retention is 0 because I cheated a little bit. And so there's all this information because, again, like I tend to say, it wouldn't be Oracle if we didn't give you, tons of information and options and this and that. So, but let's see, what else do I have here? I kind of did just the basics of the table. And one of the things that Maria then said, and which I thought I'd show, is what happens if we want to try to update one of these rows? And lo and behold, you don't get to, because it's a blockchain table, it's immutable, so you don't get to change anything. And by the same token, you don't get to delete. So you can't update, you can't delete, you can only insert into the table. You can't drop it unless, of course, you've met the retention period. So the idea is that your data is safe and unchangeable and meets the blockchain criteria. So anything else, Maria, that you would want to contribute on the blockchain end of it before we move into
I think for
more familiar
most
territory?
people, I think for most people, the view you've just shown us, where you showed us ID, user, and value, because I think if you do a typical select star from table, that's all you get to see.
Right. Exactly.
All the other columns you've been sharing with us are hidden virtual columns that are automatically maintained and created by Oracle. And so from an application point of view, it is just a very basic table. It's just, it has these extra security characteristics to it that allow you to be certain that no one is going in and illicitly changing the data in here. So, for things like financial records, ideally my bank account, right? I don't want the bank employees to be able to change the balance unless, of course, they're,
well, they're going to give you a raise.
Yeah,
or
exactly.
But yeah, exactly. Well, they come after you for that. So,
but do you know what I mean? It's for those kind of important things, or property titles, contracts, things like that, where you don't want anybody to be able to go in the back door and kind of change things under the covers. That's where blockchain makes it really, really useful. And what's fantastic about it is, for existing applications, you can change one or more of the tables in that app to be a blockchain table, but the application itself or anybody querying that table doesn't need to know anything about it, because, as you said, all of these are hidden values.
Right. And it's like when we talk about virtual columns as in-memory expressions or things like that, you don't need to know any of that stuff. It's basically just, from an application standpoint, it just literally looks like, it's no different than, as you said, doing I'm going to type now. So a select star, which maybe is what I should have done, because from an application perspective, it's just a table. And other than restrictions on certain DML operations, the application doesn't need to know, and you don't need to know about any of the stuff underneath the covers unless you're trying to go through and do some verification. So blockchain, no big deal, right? So yeah, Andy, quick question for you. I know we chatted back and forth about whether it was worth doing or not, but Bob is asking, are we going to share the command to validate a blockchain table? And if we don't, I can throw it into the Q&A as an answer. I have it. Oh, okay. Because I did run that query, but we talked about it and said, well, all it really shows you is that it says the number of rows you've got and whether they verified. And so it was kind of uninteresting. And so of course, I dropped it out of my demo. It's like, if we have time at the end, I'll go dig it up. Maybe we can, or you can, if you want. But yeah, I'll pop it into the Q&A for Bob. But honestly, it's super easy. There's a new package, DBMS blockchain. And it's blockchain table, sorry. And it's just a call of a procedure in there. And as Andy said,
The procedure simply just returns how many rows within that table it was able to validate. So you just compare that number to the actual number of rows in the table. If they match, all is good. If they don't match, then there's other procedures you can use within that package to identify which are the rows that are an issue.
Yeah.
There's another question for you too, Andy.
Okay.
John wants to know if and he needs to recompile his application if he switched a table to be a blockchain table.
No, it's just a table. So, well, I suppose if I mean, other than the normal semantics of PL SQL, if that's what we're talking about, of if a table were to change, but as far as the application, no. Can you do an alter table block? You can't do. You have to create it, don't you?
You have to create it.
Yeah.
So other than the fact that you'd be renaming objects under the covers,
Yeah,
for
exactly.
example, that's how I would do it anyway. I'd create the blockchain table. I would rename the existing table, create the blockchain table, and then do an insert for it. But from that perspective, there is no code recompilation as far as I'm aware that you'd need to do that, just because the object structure hasn't changed from the application's point of view, as you just said, Andy. You know, your trade ledger prior to being a blockchain table had 3 columns in it. The new trade ledger that is a blockchain table also, from the application's point of view, only has 3 columns in it. So
yeah, actually, where I thought he was going with that was I'm maybe if you have PL SQL packages, they might have to get recompiled when you access them the first time if the objects changed underneath the covers. But all right, so let's switch over to, can we now use our trade ledger table in the column store? So the in-memory part of this. So hopefully, if you're not comfortable with what we showed you with the blockchain table, you can go play with it on a Live Labs or go read about it. But really, there's not a lot to it. Obviously, the devil's in the details, just like it is with everything else. But ultimately, we've created our blockchain table. We've put some rows in that table. And now let's see what we can do with database and memory, because you might have an application where you have a mixture of a few blockchain tables and normal tables, and you want to run database and memory because you're going to do analytics on it. So let's see what happens. So what we're going to do is we're going to just alter our trade ledger table to be in memory. I set priority high, so it will get populated when we restart or when we create it, but we'll just go ahead and force a repopulation just to make sure. And hey, all that works. So this is a new environment I built. So I wanted to make sure that all that, I was hoping all this would work okay. And then we've talked about this in the past, but how do we tell whether objects are populated in the column store? We're gonna look at $IM segments. Oops, should probably make that look a little nicer. So we've got our trade ledger table and we've populated it in the column store. So bytes not populated is 0. And just in case you're interested, literally just looking at $IM segments. And we've kind of talked about that in the past. $$ in memory area kind of shows you how much space and we've allocated in the column store, and then $IM segments shows you each of the objects that have been populated or could be partially populated in the column store. So we now see the trade ledger is populated. It's a blockchain table, but realistically, it's just a table. So it is fully supported by database and memory, which helps with what our topic is today. And then, so let's do a simplistic table. So we'll do a simplistic query. We'll just sum the value from our trade ledger table. We get that, and then, whoops. When I was doing this, this goes back to sometimes our hands-on labs. We're going to do that twice because since I basically just started this database up, we're going to make sure that we've parsed the query. We're going to make sure that we don't do any physical reads so that I can show you that it's truly an in-memory query as opposed to maybe the optimizer thinking it's in memory, but it's really going to go to the row store because there's something about a blockchain table it can't access. And since that's hopefully provable that that's not the case, I ran it once just to get things run. We're going to reconnect so we get our statistics reset. We'll run exactly the same query again. And then we'll go ahead and see what the optimizer thinks it's going to do. And lo and behold, table access in memory full. And then our normal imstats command, where I'm showing you the session level statistics, which is why I reconnected, so they'd be zeroed. And notice that we're scanning in memory our 4 rows. We've talked about projected, not to get into too many details, but ultimately that just returns one sum. And we've done no physical reads, session logical reads versus IM. Actually, probably because of the other columns. I'm not sure why these diverge, but the bottom line is that we've got one IMCU. We've read that for our 4 rows, and we've returned that as part of database in memory. So with that, I don't really have a whole lot else. Oh, so let's do something. So are there any other questions before I move on to
yeah.
some fun? Let's just talk about, we'll talk about any questions. So
the chat has been blowing up. A lot of it on just general blockchain stuff, but so is there any other special requirements other than greater than 19.10 to support blockchain tables was one of them. And no is the answer to that. So blockchain tables, if you recall, is a new feature in 21C, but because 21C is an innovation release and it's not a long-term support release, 19C is the long-term support release. Customers were so interested in using it or taking advantage of it, we've backported it. And so the first RU that has blockchain tables in it is 19.10. And so once you're on 19.10 or 21C, you can take advantage of them.
And that's in the cloud, anywhere 19C runs, correct?
Correct. Yeah. Anywhere 19C runs, whether it's in the cloud or on-prem, as long as you're at 19.10. And so if you want to try it out, how I play with it is I have an always free tier database on the Oracle Cloud, which is always free as the name implies. It has 21C already there. And so you can create blockchain tables, try out all the stuff that we're talking about on that free tier. One of the questions, Andy, is more to you. For these blockchain tables, given that the fact they have all these hidden columns, do those columns automatically get loaded into the in-memory column store? Do you need to manually specify them to get them in there? Or should you just let Oracle take care of it?
The easy answer, and of course the one that we did here, was just let Oracle take care of it. To be honest, I haven't played around because they're hidden columns. I personally, I didn't care.
Yeah, and because you're not really querying those virtual columns, I mean, Oracle uses them under the covers to maintain the security for the blockchain table, but no end user is going to query it. I don't think there'd be any need to manually make sure those columns are in the column store.
Right. I suppose you could, there could be space issues, but I don't, you know what, maybe we'll have to experiment with it. I say this a lot when we do these sessions. Maybe I'll do a blog post and talk about that. I'll investigate it. If you really want to know and don't want to try it yourself, which obviously you could, send me an email and I'll investigate it and let you know, because
So the next question is, I'm on 19.10 and I can't you create a blockchain table. Are you sure you have the patch correct? And it is in 19.10, but I forgot to mention that there is a one-off that's required on top of 19.10. 19.11, no one-off is required, but in 19.10 there is. So let me just...
Those details get us again, don't they?
I know. I'm putting a link in the Q&A and we'll put it on the screen in the video. to Connor MacDonald's blog post that gives you all the information about what the one-off is that needs to be applied in order to get this to work. So my bad. Yeah, basically we forgot a .o in the like, if I'm going to be honest, that's what happened. We backported and we forgot one of the .os and we built the RU, and so that's why it's not working. But there's a one-off patch that fixes that and you're good to go. I've got another question about in-memory automatic level, Andy. So if I set the parameter in-memory automatic level, does the algorithm that manages the data consider blockchain table data?
Yeah, it's just another table. So it's just going to, remember we kind of talked about the fact that if you haven't already altered the table in memory, we're going to, if you set it to high, we're going to change it. Blockchain tables are just tables. I guess that's kind of the point of all this, is it's just being treated as another table. So whether it's blockchain or not, so I guess we could modify our tables, partitions, subpartitions, and materialized views to be blockchain tables, but realistically, it's just a table. So yeah, AIM is going to support all of that as well. And what else to say?
Awesome. Okay. So the next one is more of a discussion on blockchain, but it's, what if there's a valid or a legal need to update a row to correct one of the column values in a blockchain table? And I'm very sorry, that doesn't work. So what some of our customers who were involved in the original beta for blockchain tables did when they encountered this was they basically added a version column to the table so that you would select the values with the latest version ID or key or whatever. And so that's how they were able to do it. You need to insert a brand new version of that row. And of course, you can't delete the old one. So you need to know which is the new or which is the old version. You could also use, of course, the hidden create column. So if you had a unique identifier or some way to identify the row, you could also just ask it to select the one with the most recent created date. But there's no way to go back in, even if it is a valid business scenario, and modify any of the rows in the table. All you can do is insert a new version of the row and then somehow know within the application that that's the correct version.
So that might be, you might have like use your own created date column, like a lot of our applications do, and then you just select the most recent created date along with your other filter criteria.
Yeah, I mean, so I know, for example, in insurance companies, this comes up a lot because my policy is year over year. It's the same account number, it's the same policy number, but I renew it every year. They have a set of dates in that table that say this policy, you know, this iteration of this policy at this price, etc., is valid only for this period. And so when they query that, they're looking for policies, you know, within that are currently valid or whatever. And so they always put a where clause predicate on that valid period. And so it's that kind of thing. You need to have some way to identify this is the latest version of that record. And unfortunately, because it is an immutable table, data can go in, but nothing can be changed. That is something that you'd have to accommodate within the application. So, you know, going to a blockchain table, it offers you great security and stuff, but immutable tables do have this side effect that your application needs to be able to accommodate those differences, because there's no backdoors, folks. There's no way in, oh, well, I'm a sysdba and therefore I should be trusted. With blockchain tables or immutable tables, the goal is no one is trusted, and therefore we can really be sure this data is safe.
That makes sense. I mean, that's kind of the whole point of the blockchain, right? So
yeah. Andy, do you think you could go back to where you created the table? Eric's got a question. Can a blockchain table be removed, or can you ever remove the blockchain attribute from the table? And you can't remove the attribute, but can you talk a little bit about how you can get rid of a blockchain table?
Okay, so I'll let that, well, that was a nice segue into kind of the last thing I had to talk about. But notice, and I discovered this when playing around with this, getting ready for this session, but no drop until 0 days of idle. So guess what? If we want to, we can, and this is kind of what I wanted to do next, was we can say drop table, assuming I can type it, which I can't. So because I did 0 days, I can drop the table. But what I originally started with, an example I had prior to that, was I started with this example. Notice I have here 31 days. So now we've created our table with 31 days. We'll just put the rows in just so we have kind of an apples to apples comparison, since there aren't very many of them. So now we have the same table, but realistically we've created it. And to be honest, my guess is people would probably normally do this in terms of years, not days. So, but we've basically said nobody gets to touch this table or drop it and for at least 31 days. So now what happens if I try to do exactly what and this is what I discovered, because to be honest, I put this in the SSB schema, which I normally use for all of our demonstrations, and wanted to, get rid of it to clean it up and start over again. And guess what? Nope, you don't get to drop that blockchain table. So not only can you not update or delete the rows, you can't even touch the table, which is kind of the whole point. Because what if somebody dropped the table, recreated it, but maybe gave Tom, if this was his salary, put in there, 10,000 or something. And so all of a sudden he got a huge raise because, well, I can't update that row, but I could sneak a new table version in there. And the prevention, of course, with that also is all the hash chain cryptographic checks that you can do. But realistically, we don't want anybody mucking with the table container, if you will, in addition to the data within that container, right? And within the table. So more realistically, you would put a retention such that it prevents people from doing that kind of thing. And as far as I know, the way around this would be you'd have to drop the entire schema, which obviously would be a DBA thing, and presumably auditing would catch that if you tried to do that. But we've tried to make this, and for what little I know about blockchain, I'll defer to Maria, but we tried to make this pretty foolproof so you can guarantee that you have secure data.
Yeah, no, Andy, you're absolutely right. The whole point is to keep this as secure as possible. And obviously it's not every table in an application that should be made into a blockchain table.
Yeah.
And they can be used in, obviously in the same transaction, the same query as non-blockchain tables. But it is for that critical data, like I said, the contracts, financial records, titles of properties, all of those things where it is typically a write once, a read many scenario, and you want to make sure that no one has an opportunity to tamper with that. Now, there are a couple of other questions, Andy. What does idle mean? Is it days since queried or days since inserts? And I believe it's both. So idle is basically no reads, no writes on that table for those number of days.
I'm kind of chuckling because I had a feeling this might happen, but we did try to say that it's database in memory and blockchain tables, not blockchain tables. And then here's all these. So to be honest, I don't pretend to be an expert at blockchain tables, and even Maria probably hasn't spent huge amounts of time on all these different options. So I'm not the guy to ask. And
no, but I had that same question, so
yeah.
I'm fairly certain I've given you the right answer, because it is, when you see that syntax, the first thing is, well, what does idle mean? Idle is a new kind of concept to Oracle database users or for tables. And so as far as I recall, but it's all, so the good news is the documentation is extensive for blockchain table. Because it is such a new concept, we did put a lot of information in there. One of the other questions that's in the Q&A right now is, can I truncate a blockchain table? And the answer is no. So it's one of those things where, again, it's to stop somebody who is a powerful user, so somebody like the DBA, from being able to undo by completely replacing all of the data. So, I mean, we can try it there and you can prove me wrong. See, operation not allowed on a blockchain. Phew. I did remember that correctly. So what I'm saying is there is lots of restrictions on them because of the nature of the table. So it isn't for every table in your application, but they are incredibly powerful for what they really are used for.
And if you, since you have your entire application, your schemas, if you're using analytics and very likely might want to run analytics against blockchain tables as well, you can populate them in database and memory and along with your normal data and do that. And so that was obviously for me the point of our session here, but some great blockchain questions. And it's going to be one of those things I think that people are going to be very interested in. So we might have to do a little more. We were, like I said, we kind of just decided to throw this together. It would be kind of cool based on the previous Ask Tom session. Why don't we show this? And I guess we could have. Yeah, I think we've done okay. I think we've kind of shown the point. I don't pretend to be an expert on blockchain, but
no, and it's very new, so I think it's exciting that people are happy to try it out. So unfortunately, lots more questions on blockchain tables. One of the questions is, and Andy, since you've been playing around with this, after the set period of idle, in other words, as long as it's now valid to drop the blockchain table, if I drop it, can I create that table again with the same name, but different values in it?
Yeah. Well, yeah, I did that actually, right?
Right.
Because we had trade ledger with 0 days, and then I whoops, way back when we started here, and then I dropped it and recreated it. So yeah, the answer is yes. So we actually did that. So we dropped the table. Whoops, not that one. Where was it? Right there. So we were able to drop it, and I recreated it with the same exact name. So yeah, which is like any other Oracle table. So there's no, I don't know, I guess there's no remnants because we've dropped it. All of those hidden columns are what keeps track of everything. So there's no pieces laying around anywhere else within Oracle database that might trip you up as opposed to how a normal table would operate.
Exactly. It's supposed to behave exactly the same as a normal table after that idle period has expired.
Right.
Somebody's asking, isn't that a problem that you can create the exact same table? And this is where Andy was pointing out, you need to be careful with the value you specify for that idle time.
Right, because it could be a problem, right? I mean, somebody snuck one in on you, but then again, this is the blockchain. I think in your presentation, you talked about the signature and storing the hash value or the signature value outside the database as well. So then when you do the verification, you know that it not only is it those tables or those rows haven't been tampered with, but they're the same rows, right?
Exactly. Yeah. Because you can share the cryptographic digest, that would be the way to make sure if you were worried about that. First, set your idle days to a value that shouldn't allow that to happen. And if you were worried about that, then publishing or saving, at least outside of the database, the cryptographic digest, that way you could do the comparison, would be an easy way for you to do it. Couple of other questions. And Andy, I think you showed some of this. John is asking that if I switch to blockchain tables, are there special application codes or application code that should be used? In other words, is there something about verifying the data that should be added? Are there error messages that are new? And you did show us those error messages that are new. For example, you showed us for the truncate as well as you tried to update, I believe, and delete from the table. So there are new error messages, that your app should be aware of.
Yeah, that you probably would want to capture and say, oh, well, you can't do that. There is, unfortunately, I guess there is a verify rows. There are some, as Maria pointed out, some administrative, I would say, I don't know that you do it in the application, but maybe administrative procedures to make sure that you keep track that nobody's tampered with the table. I'm not sure whether you would do that in your application or not, but as far as the table, other than the restriction of not being able to do changing the rows, you just do inserts. It's just a table. I don't think you need to change, but I mean, maybe you do.
No, I can't think of anything either. As you said, you could periodically run the verification process And if you're interested in that, I put the code for that in the Q&A. The answer is
Thank you.
there in the question that got asked earlier. So if you want to go back and look at that, John, you can. And maybe, Andy, when we do the video, we can put up a
Yeah,
little
I'll put a
window
little,
that'll have the
yeah.
code in it so that people can see it. But it's super easy. It's a supplied package that you just run. And as Andy said, it just gives you the rows that were the number of rows that were verified. You can compare that to the number of rows in the table. If they match, you're good to go. But otherwise, it's just really the error messages, because there are a lot of new error messages. It's the same error message. So once you capture that in your code and you know what to do with it, then you should be good to go. But it basically, this operation isn't allowed on a blockchain or a mutable table. It's the one you're looking out for.
Yeah, maybe I'll put a blurb in about steal something from your slides and the external, saving that hash outside the database, because I think that was a big part of it to help you validate that nobody's tampered with anything.
Yeah, exactly. Yeah. Next one is, since blockchain table rows depend on the row prior to it, does this have a performance impact for large inserts, like doing an append or a parallel hint work? So first and foremost, direct path loads on this first version of blockchain table do not work. So because we have to cryptographically chain the rows and we have to see the value before it, doing create table as selector, insert appends don't work. Standard insert works, obviously, but insert append does not work. It's a restriction in this first version of blockchain. The performance impact, I didn't really notice it, but obviously there is some work we're doing in the background. So if you've got a very sensitive application, it would certainly be worth doing some testing. Andy, I don't know whether you noticed any slowdown when you were doing your testing with it.
No, but I never had, I'm not doing millions of rows. I didn't try huge volumes of data, which I guess potentially could be something that might be an an application might do. No, I mean, it just, my few rows that I was playing around with, I didn't notice anything. It's so fast. But again, when you get into the millions and billions of rows, then that scaling, it might, I don't know. I suppose once you get support for direct path, then I would imagine it won't be, that's just going to be some CPU, and I suppose that would be fine. But I didn't notice anything for my onesie twosie examples.
Yeah, me either. I never noticed it, but you're right. If you've got something that requires microsecond response times, maybe it's worth, because there is some work going on in the background. Oh goodness, right, they're flying in. Are there any additional storage or other resource requirements for these blockchain tables because of the additional processing overhead? I don't know whether you noticed the footprint of it on disk. I mean, if Andy, can you scroll back and show us the virtual columns that are being added to the table? I think you've got them there. I mean, most of them are just numbers. And so they're very, very small overhead. But yeah, the table would be a little bit larger, because for each row in the table, we're maintaining those extra columns. So they would be a little bit larger than non-blockchain. But other than storage and a little bit of additional CPU on insert, there's really no other overhead as far as I can think of.
I'll just use one of you, a line I steal from you periodically is, nothing in life is free. So obviously there's a cost to maintaining all of this, but I suspect that in the long term, the benefit far outweighs the cost. Same when we'll go back to something I like to talk about with database and memory, is when we do virtual columns, we do in-memory expressions. There is, when we show in the labs that there is extra space used for those in the column store, but the benefit, typically far outweighs that cost. And so it's like, nothing's free. So.
Exactly. Speaking of free, one of the questions that we've got is this an additional cost item, or is it just part of the database since it is just a table?
Yeah, it's just part of the database. So they don't, in memory doesn't care. Database and memory, there's no special feature restrictions. As far as Oracle database, I don't think there's any feature. You said that earlier, actually. There's no, it's just part of Oracle database.
And then the last one we've got is blockchain is usually a distributed ledger that's peer-to-peer networked. So how do blockchain tables fit in with that? And it is valid. Normally, as you said, it is normally with the blockchain architecture, you are trying to prevent illicit changes by bypass the database by doing this peer-to-peer network or architecture with consensus-based multi-party agreements for every change. But the problem with that is that requires a completely new architecture for both the development and the deployment of those applications. And so because of this consensus requirement, it's a major change to the way you do your business and the way you implement these applications. And so although blockchain table gives you that protection from illicit changes, because those illicit changes either can't happen because you can't do the DML, or if somebody does destroy the schema completely and puts a brand new version of the table in there that's now changed, in that scenario, because we have the ability to check the cryptographic chain, we would have known that it's been tampered with. So if a criminal knows they're being videoed, they're much less likely to commit that criminal act because they can be caught. And so although peer-to-peer, where you're doing that consensus basis, would mean changing the entire schema wouldn't have been possible, it is technically possible with blockchain because you could drop the schema and create a new version of it. But by distributing the cryptographic chain or the cryptographic hash information outside of the database, we can then verify it. So therefore you can still be caught doing it. We believe that it's good enough because what we were looking to do was give you the benefits of blockchain without requiring you to change the way you develop and deploy applications or the way you do business. Because after all, you know, these important pieces of information, our bank statements, our property titles, legal contracts, they're already stored in databases. They're already used by existing applications. Moving that to a full blockchain architecture that is peer-to-peer, that is using consensus-based multi-party agreements for every change is just too heavy, we think, for most enterprise applications. So, Sergey, hopefully that answers your question. And with that, Andy, I think we're pretty much at the top of the hour or close to. Is there anything else you want to put in before we finish up?
No, I think we've covered everything. I'm amazed at how much interest in just the blockchain tables there are. And so I would strongly encourage you to go back and look at the beginning. Maria did her slides, and she had a bunch of resource links that you could get more information. Hopefully we've done justice to the blockchain tables, but also shown you that with database and memory, you don't have any other restrictions. You can actually incorporate this into your analytic processing and queries. And so I just want to, I'm amazed we were able to get so much interest, and I think that's really cool. I think people really are interested in all the new features in Oracle Database. And with that, I don't have anything else. Oh, there you go. Yeah.
Yeah, so I'm just going to throw that up just so that we can end on this. As you said, Andy, there's lots of important info out there on this, and given the interest, I guess it's.
And I think the coolest thing is you can go try this on your own, because even if you don't have anything on the cloud, you can go run their hands-on lab for live labs and try it out. So you don't have to take our word for it. You can actually go try it out. I don't know that you can do the database and memory part, but you could certainly go do the database and memory live labs. I think it's maybe not. You might have to, I'm not sure what version right now that's running on. So, but certainly for the blockchain part, and as you can see, it's just another table with database and memory. So I think between the two, you could probably get a pretty good feel for how that all works.
Absolutely, yeah, because the Live Labs database and memory portion is fantastic. I've also done the Live Lab for blockchain tables. So if you haven't tried those out, they're an amazing resource and incredibly useful way to get familiar with new technology without having, as Andy said, to install a new 21C database or a new 19C database just to try this stuff out. It's all available there for you on those live labs. So great way to get used to it. As I said, because it is new functionality inside the Oracle database, we have a mass of documentation on it. So all the information you would need there, as well as examples of how to verify a blockchain table and the contents of it, is all in the documentation as well.
Great. Well, thank you very much, Maria, for joining me again and bringing all this information to add to the database and memory part. So I think this, and obviously with all the questions, it was we had a lot of interest. So that's pretty cool.
No, it's great. And thanks so much for all the folks who attended today and attend every month with Andy and I. We really appreciate it. We hope you find the sessions useful.
Yes, thank you.
Thanks so much, folks.